making sure that we can find the max and the min ourselves. So you should have this all filled out, right, from last night? All filled out. On the back, this part right here, we want to make sure that you guys can find the other maxes and mins. All right, so we had the the minimum right here, the 1.838, negative 3.310. We already found that one. So that one we can go ahead and write down. All right, let's find the other max, the other min. So we're just going to go ahead and type in this function. I should hear some clicking because everyone's going to do this. We're just going to make sure that every single person can find the max and the min if they need to. Oh, calculator? Nope, but you need a calculator out. Because that's what we're doing today, is finding all this stuff. So I can tell that the max is, it looks like it's probably at 0, so I'm just going to check for the max between -1 and +1. Left bound -1, right bound +1. Like I said, I'm not a big fan of scrolling if I can avoid it. For those of you who are in the process of finding the max right now, it looks like my x-coordinate is -2.277. Those of you who are finding it are probably getting different decimals from that. So what issues are we running into with finding that maximum? So look what it says. This is where we have to be careful. So I talked about this in the video last night. It's trying to say 0, which is why mine might be slightly different than yours. Anyone else get a little E thing right here when they tried to find their maximum? Yep. Did your E say the same thing as mine, though, or was it slightly different? It's probably slightly different for everybody. So this is something to watch out for today. Now, when I looked at this, I figured the x-coordinate would be 0. I figured that maximum was on the y-axis. I figured that x value was between -1 and +1, so like at 0 is what I expected. So you have to be careful when you look for these, that you're not just mindlessly writing this down, because this is a problem. It would not be mean for me to put this on a quiz, because this is a regular issue, in particular with polynomial functions. Your calculator has a hard time, for whatever reason, with polynomial functions and getting the 0 value exactly accurate. It just, for whatever reason, it has a hard time. So it's not mean for me to put this on a quiz or a test. And sometimes I might put one of these on a quiz or a test unintentionally. I got this example and I didn't even know it was going to do this. Okay, this was like totally on accident. The other example I got that did this, the one after this where it did it, that was on accident as well. So the two examples that showed up on these notes that were like perfect for them to end up being on notes, because it happens so common in this unit, those were not intentional examples. Those literally were completely coincidental, and they just happened to be there, okay? Because I just randomly picked some examples from a worksheet generator. I did not make the notes I did not like make the answers for the notes ahead of time. I just winged the notes like I winged the video as I made it, and they both happened to do this. That's how common it is. Does that make sense? So it is fair for me to give you something like this on a test because it really is that common. You just have to know that's what your calculator is going to do. Your calculator does have a hard time with those. Okay, so this maximum is the 0.05. Do not give me decimals. You need to see that and you need to recognize my calculator is struggling to say 0, but it does mean 0. This is the 0.05. Okay, so for maximum, we got 0.5. There's our mountaintop. And then we've got one other little valley there. And for the valley, the minimum, I am going to have to scroll because I can't really see. Well, I guess it kind of looks like it's on either side of 1, so maybe I could say it's between -2 and 0. I guess I could do that. So I could do my left bound as -2, my right bound as 0. That works. Okay. So sometimes with these you can scroll left and right to find them. Sometimes you can plug in the numbers to find them. Are we comfortable with finding the max and mins on our calculators? Okay. So I just put a comma here. I did not put a U. Does anyone know why I did not put a U? Kind of, I should, if they asked for the minimums, I really should have both answers. It's a different reason than that. No, that's not it. No. So the U happens with interval notation. So on the problems where we have a U, the problems like the increasing and decreasing interval, your answers are an x value to an x value union an x value to an x value. That's how they're written. It's interval notation. It's one interval and another interval combined together, okay? And that's where the union happens, is you're saying, where is it increasing? And you're saying, this is the whole increasing answer. It is almost like a math sentence. Does that make sense? The idea is it's like a math sentence. When I'm talking about max and min, I'm not talking about a math sentence. I'm almost like talking about names. I'm saying an x and a y coordinate and another x and y coordinate. So that's why I'm not putting a U in between. It's not an interval. It's not a sentence of something. It is one thing and another thing. I still need both of them to be right, but I'm not writing a complete interval of something. Does that make sense, the difference between those two things? Okay, so that's why I have not marked anyone down. Some people have put U's in between 2 points, and I scribble it out. When you do it, I scribble it out and I say you shouldn't put a U there, but I've not marked you down because I'm recognizing that you're still figuring the U thing out. Okay, so interval notation, when you're talking about an interval where something is happening, that's where U's happen. But in between 2 points, when I have an x and a y coordinate of one location and x and a y coordinate of another location, we do not put U's between that because it's a different type of location, or a different type of notation. It's just saying points. Okay? So U's only happen in things that can have brackets and parentheses. Points never have brackets. Points are always just x comma y within parentheses. It's just a point. Okay? These intervals, they can sometimes have brackets, right? We've noticed that with range and stuff. That's where you can have the U, okay? And as much as you guys need me to repeat that until it kind of gets in your brains, let me know. Same as Rise 1, can you have the U again? And I'll explain it again, okay? Because I know that's kind of confusing, okay? So the U is only necessary when your answer is an interval. It is not required, and it's incorrect to put it when your answer is points. Okay, x and y points. Intervals are answers like this. Where is something increasing? Where is something decreasing? What is a domain? What is the range? Those are interval answers, and those can have U's. Answers like what is the x-intercept? What is the y-intercept? What is the point where the max is? What is the point where the min is? Those are things that are locations. They do not have U's in them. They are location answers. It should not have a U. Okay, does that make sense? Okay, so we are actually doing 2 things today. I'm going to give you guys some time to work on this part. So this part is a calculator activity. It is not mathematically taxing. It is not mentally taxing. It is just lots of clicking. So I'm going to give you some time to do the clicking, and then we are going to move on to something that is more mathematical, okay? So even though I'm telling you that so that you can pace yourselves. Don't feel like you have all period to do this assignment. You don't. So don't dilly-dally. Does that make sense? Don't just like goof off. I'm not going to give you both because the second one will make no sense. We got to do notes for the second one. Okay. To clarify though, we do not have, hey guys, listen carefully. As you have a note going to do a notes video tonight because I'm not going to give you that much homework. So we are going to do basically what happened is the timing of how many days I was able to put into this unit. I had too many concepts and not enough days. So one concept had to go into an extra concept had to fit into a day somewhere. And today is the day because this is not difficult for us. We've done these characteristics a bunch of times, right? And finding stuff on the calculator, we can do that. It's not too bad. Yes. 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 All right. All right. If you look at number 3, do you guys see how it just bounces on the x-axis right here? I think that if you try to do the left bound, right bound, your calculator isn't going to like it. But let me double check. If you try to do left bound, like 1 to 3. Oh, it does. Okay. So, I think some of the older calculators won't do that. Oh my god, did you try it? Because yours is the older operating system. Have you tried number 3 yet? It did it? Okay. Okay. Never mind. So that one, well, I just recorded for nothing. Continue. Keep going. Okay. So here are the notes. So before the quiz, we were taking problems, and we were starting here, and we were looking to see if we could find what the roots were. Okay. So we were starting here, and our goal was to make it backwards and figure out what the answers were. That was our goal, okay? So today, what we're going to do is we're going to start with the answers, and we're going to work our way from the answers to see what equation it was that gave those answers, okay? So today we are writing equations from real and complex roots. Before we were finding real and complex roots from the equations, today we have the answers, we're taking the answers, we're writing them back into the equation form. So this math that we are doing today is literally how I would come up with the problems that you guys used on your last worksheet that you did for finding real and complex roots, okay? So what we do first is, it's easiest if you start with real answers. So if we started, and this is a problem you've seen before, you've seen stuff like this. If we started with x equals 2, and x equals 4, x equals 2, x equals 4, then in the factored form, that's x minus 2, x minus 4, right? Would you guys agree with that? Mm-hmm. And then to find the quadratic, you would just take those two things, you'd FOIL it out, this is what you get. You combine like terms, and then this is your answer, okay? So here's what I want you to write in your notes. I want you to write that this is called the linear factorization. So the linear factorization is what we liked when we were graphing these, because we could see what the x-intercepts were, we could see what the multiplicity was, it made it simple for us to graph them. And the standard form is what our instructions are going to ask for today, and standard form means we got to FOIL everything out, okay? So today is going to be about foiling stuff out. All right, the next problem. We could see two x-intercepts. We could see an x-intercept of -1. We could see an x-intercept of +3. But on that x-intercept of +3, it bounced. Does everyone see the bounce on +3? So that +3 had a multiplicity of 2. Everyone comfortable with that? Okay, so that means we had an x plus 1 and an x minus 3 squared. We had an arrow going up first and an arrow going down second, right? So this, we had answers like this the other day. This is the linear factorization. Go ahead and write that in your notes. Linear factorization. So we're going to be paying attention to instructions now, because if the instructions say find the linear factorization, we're going to go, oh, thank goodness, I do not have to FOIL anything. And if they say find the standard form, we're going to go, oh, yay, foiling is my favorite. I love it so much. All right, so this one, it wanted the standard form, so they said negative x plus 1, and then x minus 3 times x minus 3. Since it was a multiplicity of 2, they had to write it twice. See that? So what I did is I took this and I FOILed it. See that? I FOILed it. And then I took the x plus 1, and this is my method of multiplying things out. Anytime I'm doing two terms, a binomial multiplied by a trinomial, I always use a box to multiply. And that's not like, oh, I'm a math teacher, so I'm going to tell them to use a box, but I'm not going to use it myself. That is, I'm going to use it myself too, because I found that when students multiply a binomial times a trinomial, they usually make mistakes. So using the box to multiply is a good way to multiply without making mistakes, okay? So what you have here is the typed up version of a perfect example. It's very distracting. James, can you do the little twisty, or I don't know where the twisty is on what side, but can we close those blinds so it's less distracting? No, at least we can only hear it and not see it very well. Okay. So, and if you guys can see that little coefficient of the negative, I waited until the very end, and then I took that negative with the coefficient and I distributed that at the very end, and then this right here is my standard form. So now we're going to write standard form. So the standard form is the goal today. And the last example on that page does not have the answer, so we're going to actually go through the process to find this, okay? Are you guys ready? Okay, so let's follow these steps. So first step is to write down the actual answers you can see. So what answers do you see on this page?
5, 1, negative 3, 4.
Okay, so I see x equals negative 5. I see x equals negative 1. I see x equals 3. And x equals 4. And then I can see that both arrows are going up. So is that a positive coefficient or a negative coefficient? Positive coefficient. Okay, so this right here is a positive coefficient. Okay, so that's nice. Okay, so now, do you guys want to do y equals or f of x equals or g of x? What do you guys want to do? Y. Okay, we're going to do y. So let's write y equals, and then let's go ahead and do the linear factorization form, or the factored form. So how do we write it? Okay, so this is the linear factorization form, and depending on the instructions, maybe this is it. Maybe that's all they wanted. But these instructions, for the examples at the top, it says find the standard form. So that is not all they wanted. That means we got to do some foiling, okay? So what I'm going to do is I'm going to FOIL these two together, and I'm going to FOIL these two together. Miss Rice, why did you choose those two and those two? Well, because they were right next to each other. That's why. Okay, so go ahead and take a moment and FOIL these out and see what you get, and FOIL these out and see what you get. So x plus 5 times x plus 1, FOIL it out. X minus 3, x minus 4, FOIL it out. Okay, How did you guys do with your foiling? Did we get what we should have gotten? Yes? Okay. So we are multiplying a trinomial by a trinomial. If we were to do the FOIL method, I'm going to tell you how to do it, but I do not recommend it. If you do the FOIL method with a trinomial times a trinomial, you would do the first term times all three, and then the second term times all three, and then the third term times all three. That's how the FOIL method works. Okay? The reason I don't recommend it is because when you do that, 3 terms times 3 terms is going to give you 9 terms. It is really easy to miss a sign, make a little mistake, have a hard time adding like terms, something. Usually when students do this, they make a mistake somewhere, get the wrong answer. This is usually where things go bad, okay? So instead, we're going to do a box to multiply these out. Think of like a multiplication chart back in the day. And since we're doing 3 things by 3 things, it's going to be a 3 by 3 box. And most students get these right every time when they use a box. It does not matter which one you put on the top and which one you put on the side. Doesn't matter at all. So I usually do the first one along the side. So x squared, positive 6x, positive 5. X squared, negative 7x, positive 12. And then we're going to go ahead and multiply. So x squared times x squared is x to the 4th. X squared times negative 7x is negative 7x to the 3rd. 12 times x squared is 12x squared. Six x times x squared is 6x to the 3rd. 6x times negative 7x is negative 42x squared. 6x times 12, anybody? 72x, perfect. 5 times x squared. That was laziness, by the way, because I don't know my 12 times tables. So I was asking, so I wouldn't have to do it. 5 times negative 7x, negative 35x. And then 5 times 12 is 60. That's the only one I know. Okay. All right, the fun thing about the box, this is what I love about the box, is that it puts the like terms on the diagonal. So there's your x cubes, there's your x squareds, there's your x's. It just organizes them really nicely, which is why I like it. So we don't have a negative coefficient to worry about distributing. We don't have a negative coefficient to worry about carrying down. We can just write the answer now after combining our like terms. So x to the 4th. And then what should I write next? Okay, and then what next? Negative 25x squared. Okay, and then 37x, and then 60. Okay. So negative 1, that's negative 30 plus 5 is negative 25. 37, yeah. Looks good. Okay. How are your brains feeling about the process? Does it make sense? Make sense? Okay. Since it's making sense, let's make it more difficult. Now, our answers did not always show up on a graph, right? Did you guys notice that? They didn't always show up on a graph? And they weren't always nice, right? The answers are not always nice, whole numbers, and clean. So what kind of answers do I get when I solve for x with the quadratic formula? What kind of answers? Say it again. Fraction answers, yes, we got fractions. What other types of answers? Square roots. Okay, what else? So square root answers were, they gave us the irrational, they gave us the crazy decimals. And then imaginary answers. So we're not always going to have like x equals 5, x equals 3. They're not always nice. Okay? Now the interesting thing about both of these, irrational and imaginary, is that since they came from the quadratic formula, let's go ahead and write the quadratic formula out. X equals negative b plus or minus square root b squared minus 4ac all over 2a. The part that we just talked about, the irrational and the imaginary, that part, both of those come from this right here, this square root sign, right? The irrational answers we talked about, they come from the square root sign. The imaginary answers we talked about, those come from the square root sign. And in front of the square root sign, we have a plus minus. Okay? So irrational and imaginary answers always have a plus or minus. They always come in pairs. They always come in pairs. Okay? That is important. They always come in pairs. Okay? I'm going to put a little star next to that. If you got a color, get it out. They always come in pairs. That is important. Look how bright that blue is. It's beautiful. No? Okay. From the back of the room. I like it. I like it. Okay, so let's do this problem. So this one, same idea, it's a quadratic, but instead of having those nice numbers like 5 and negative 3 and 1, it has negative root 2 and positive root 2, so it has pairs, right? Because those answers would have come from the quadratic formula. So we're going to write two answers. X equals what? They're already written for you. Just tell me them again. Negative root 2. Oops, that's not a 2. Negative root 2 and x equals positive root 2. Okay, do you guys want to do f of x equals or do you want to do y equals? Y, okay, y equals. All right, it's going to feel weird, but we're going to do it. Let's put these in parentheses. So what should our first parenthesis be? X plus the square root of 2. What should our second parenthesis be? X minus the square root of 2. All right, do not cry. Do not cry. We are going to FOIL this. Don't worry about it. Some math magic is going to happen. Are you ready? All right, when we FOIL, we get x times x is x squared. Okay. Outside, x times negative root 2, don't cry, is negative root 2x. Don't cry. You're fine. You'll be okay. We're going to do the inside, don't cry, positive root 2x. Okay. And then we're going to do the last ones. Okay. A positive times a negative is a negative. Root 2 times negative root 2. What is a root 2 times a root 2? A root 4. Okay. It's a root 4. Okay. Now, what happened to the middle terms? They are gone. That is going to happen every single time. Every single time, the nastiness is going to go away. Every single time. You do not even have to write it down because it's going to go away every single time. Okay? Now, the square root of 4 is also going to, the nastiness of that is going to go away because what's the square root of 4? 2. All right. So our answer is y equals x squared minus 2. That's it. So even if the solutions that we start with, the x-intercepts that we start with, even if they look bad, the equation that we have does not look bad. Because if you remember when we were doing that worksheet that had the I answers, when we were doing the quadratic formula and we had the I answers for that, when we were doing the quadratic formula and we had all the crazy decimal answers, those problems did not look crazy to give such crazy answers. They looked just as normal as all the other problems, right? So when we find the answers, when we find those equations, they should look just as normal as anything else, okay? So here is our linear factorization form. Here is our standard form. Just keeping track. All right. Let's take away the pictures. We're going to take away the pictures and move on to just words, because a lot of times these problems don't give you any pictures, they give you words. All right. Second degree polynomial, that's a quadratic, it's just x squared. Okay? If it's x squared, how many answers should I get? 2. Okay, so I'm going to start by writing x equals x equals. Okay? Now, they did not tell me both of the answers. They only gave me one. They said one of the answers is negative 3i. But we know that these types of answers come in pairs. So if one of the answers is negative 3i, the other one has to be positive 3i. Okay? All right. Do you guys want to use y? Do you want to use f of x? Do you want to use h of x? Y? You guys are really hating on anything else. Okay. What are the parentheses that we're going to do? Okay. So we're going to go ahead and FOIL this out. We got x times x, x squared. All right, now don't be scared. Don't be scared. We know it's going to clean up. So we got negative 3ix. Then we got positive 3ix. See how that cleaned up? Okay. Now we got to reach back to Math 2 for this next one. Now we got minus 9i squared. I squared equals what? Negative 1. I is the square, equals the square root of negative 1. But this is what we're going to be using today. Okay, so anytime you see an I squared, that's actually a negative 1. Okay, so let's say the nasty stuff cancels out. So this is gone. That's gone. Okay. So we have x squared. Negative 9 times negative 1 is what? It's just positive 9, so that becomes a positive 9. So we have x squared plus 9. Okay. All right. A third degree polynomial. How many answers do we have? 3. Okay, we got x equals, x equals, x equals. Okay? The roots are negative 2 with a multiplicity of 2. So if the answer is negative 2 and it has a multiplicity of 2, how many times does that answer happen? Twice. So I'm going to say negative 2 with a multiplicity of 2. See that? I wrote that answer twice. It happened twice. Okay? And the answer 1 with a multiplicity of 1. So the answer 1, and it happens once. All right, I'm not giving you y this time. F of x, g of x, h of x, what do you want? F of x, okay. No, that's only with inverses. All right, let's write our parentheses. What are our parentheses?
X plus 2. X plus 2. X minus 2.
Perfect, okay. Now, we have to choose 2 of these to FOIL. It does not matter which 2. You want to do the last 2? Okay. So I'm going to keep the x plus 2 right here. I'm going to leave it in the front, and then we're going to go ahead and FOIL those. No, I'm just waiting for people to finish writing. So what did we get when we FOILed these? Perfect, okay. And then how do we multiply these two? Box. So you can do a 2x3 box or a 3x2 box, it does not matter. I prefer the drawing process for a 2x3 box, so I always do mine that way. You can FOIL. You could do the first term times all three, and then the second term times all three. That's fine. Although I will say, again, that's where I usually notice the mistake. So just if you do that, just be careful. Yes. That's, so if we were to graph this, multiplicity, so it's x-intercept of -2, x-intercept of 1. So this is one of those graphs where it bounces. That's how we can have the answer twice. It bounces. Because it didn't come from the quadratic formula. That's not, it's not an I answer, and it's not a square root answer. This is a regular number 2. So this is like these ones. These come from regular old factoring. They're not necessarily quadratic formula answers, so they don't come in pairs. So the only answers that come in pairs are irrational. So irrational is like square root 5, square root 11, square root 17. Imaginary is like the ones like I, square root 15, or 6i, or something like that. So since the number -2 is not either of those things, we don't assume it's part of a pair. Okay? So the multiplicity of 2 just means that when they graphed it, it bounced at that part of the graph.
I guess I was expecting it to be a -2, and then with square parentheses, it'd be a +2. I don't know what the other -2.
Multiplicity of 2.
That becomes what, x?
So this is x plus 2 squared, x minus 1, multiplicity of 2, multiplicity of 1, and then we were expanding it out. That's fair. That's reasonable. Okay. Put your face mask, just push it in a little bit so your face mask will absorb it when it comes down. Just a little dabby dab.
Should call the people who made the curriculum.
Just tell them how we feel.
Yeah.
So if you guys, for those of you who have done your multiplying, you can see that the like terms are still on the diagonal. Are we getting more convinced after today that a cheat sheet would probably be beneficial for this unit?
Maybe for some things like the I squared.
Yeah, definitely that. So we got x to the third. What else do we have? Okay. -4, yeah, because those canceled out. All right, there's our equation. Now, mathematically speaking, all of the stuff that we've done this unit does tie together. But it's I think for the level that you guys are at, it feels abstract enough that it's hard to wrap your brain around, and it might take some time before it really sinks in. So that's where I think the cheat sheet, this unit, if you did not use it on the quiz, you might have regretted that. And if you did use it on the quiz, you might have been like, thank goodness I had that for the quiz. So definitely work on those cheat sheets before the test. Yes, sir. Oh, f of x. F of x. I broke my own rule.
Yeah,
all right.
Is that a baby animal?
No. The baby animals are conceptual mistakes. All right, turn to the next page. Turn to the next page. That feels a little dramatic. All right. So I'm just going to remind you in this problem where the 2 plus 5i came from, okay? So this is a problem with the quadratic formula that simplified. The 2 came from right here. The 5i came from right here. Does that make sense? The 2 came from the front. The 5i came from the square root, okay? So when we talk about the other answer in the pair, the 2 is not going to change signs to give you the other answer in the pair. Sorry, my phone is buzzing. It's very distracting. Let me make that stop. Okay. The 2 is not going to change signs. The plus minus is in the middle of the problem. Do you guys see that? Okay. So for the other answer, we have a second degree polynomial. So we're going to have 2 answers. X equals X equals. We got 2 plus 5i. That's the first one. For our second answer, we're still going to have a positive 2 because this number in the front does not change. It stays the same, okay? The plus minus is in the middle of the problem, and so you're going to have 2 plus 5i and 2 minus 5i, okay? 2 plus 5i, 2 minus 5i, okay? We're going to do g of x this time. We're just going to make it real crazy. G of x, okay? Now, when you put these in parentheses, you have to change the sign of both of these when you put them in parentheses, okay? So we're going to say x minus 2 minus 5i. Because we always put x, right? Like if it's negative 2, we do x plus 2. Negative 2, x plus 2. We always put the x in there. Okay. The next one, we're going to say x minus 2 plus 5i. The opposite signs? You can't do plus 2. It's minus 2. So change the sign, change the sign. Change the sign, change the sign. All right, now I am doing 3 terms times 3 terms. Remember, things are going to get messy, but the messy stuff's going to cancel out. Don't get scared. The messy stuff cancels out. Let's go ahead and do a box, a 3 by 3 box. These ones especially, I do not recommend foiling because they get real weird in the middle. Like in the middle of the problem, it gets real funky. So x, negative 2, negative 5i, x, negative 2, positive 5i,
Is there another sheet?
These are notes.
Oh, this isn't the work.
No. Why would we do our whole assignment together? This is a community practice assignment, folks. Community practice. I think I'm probably going to have you guys maybe do like the first one or something. The first one on the back. Yeah. All right. What is the very last one? 5i times negative 5i? Okay. So there is some nastiness inside this box, but what is happening? It cancels, yeah. So 5ix and negative 5ix, those cancel. And 10i and negative 10i cancels. And then we have this negative 25 times I squared, but remember, I squared is just negative 1. So negative 25 times negative 1 is just 25. So the final answer is... Return it and work. No, just turn it in tomorrow. Yeah. All right, so we have x squared. Perfect.
What about the 4? Oh.
So -2, and then the 25 and the 4 gave us the 29. All right, we got one last problem to make it weird. All right. X equals 4i. If there's a 4i, what else is there? All right. Okay, but they also said there's a root of -3 root 6. Okay, now the -3 root 6, let's look back and let's think about the quadratic formula and where this was. Okay, so -3 root 6 would have been right here. That means that this part would have zeroed out. Okay, so the -3 root 6 is just negative. 3 root 6 means they simplified their radical. Okay, that's what the -3 root 6 means. All right, so -3 root 6, so what is the other answer? Just +3 root 6. Okay, so this is actually going to be a polynomial with an exponent of 4. Got 4 answers, exponent of 4. Okay, what do you guys want to have it equal? Why? Okay, what should our parentheses be? Right. Now, when you're doing problems like this, remember that when you FOIL them, they get messy before they get better. They only get messy and then get better if you multiply them by their pair. If you want to have a good cry, then try foiling these two. That will make you have a good cry, okay? So if you would like to cry a lot, feel free to do that one. But if you don't want to have a good cry, then don't FOIL those together. FOIL the ones in the pairs. So FOIL these two, okay? You have to FOIL it with its pair so that the messy part goes away. If you don't FOIL it with its pair, the messy stuff does not go away. It stays for a little bit longer before it disappears, okay? It will eventually go away, but it will make you cry first. That is not a challenge. There's always one in the class that takes it as a challenge and says, I'm going to do it. The tears do happen. Most of the students who have done, I don't think I've ever had a student who's been like, yep, I'm going to do that, and then tries it and actually gets it. So don't even try it. Just do it with the pair, and let's go from that so that we don't cry, okay? So if we FOIL this out, we've got x times x squared. And then we know, are you guys okay with skipping the part that's going to cancel out? Yes? Whatever floats my boat. So I know that there's some stuff that's going to cancel in the middle. Cancel. All right, and then I'm going to have the -4i times the +4i, and what is that going to give me? -16i squared, okay? So +16. Okay, so that's x squared plus 16. All right? Over here, x squared, I know the middle stuff is going to cancel out. And then I'm going to have 3 square root 6 times -3 square root 6. Let me just write this down. So I'm going to have minus, what is 3 times 3? Okay. What is root 6 times root 6? Okay. All right, what's the square root of 36? 6. Okay, so we actually just have 9 times 6. 54. Okay. X squared minus 54. See, it wasn't as bad as it looked originally. It looked pretty bad, but because the messy stuff disappears. Keld, I know. I know, Keld. I know. I know, buddy. All right. Now, this is 2 by 2, so we can just FOIL that if we want. Just FOIL it. You don't even have to use a box. But that's a calculator problem I'm going to leave for you guys. Yeah, I think you guys can. Somebody shout it out so that it's on video. 864 video. Do you hear that? Negative 864. And when you combine like terms,
Hard to do.
Hey, you guys don't pack up yet because I'm going to tell you what problems to finish.
I'm not gonna give you the answer. No, it's the way. Stop trying to cheat way.
No, it's the envy.
I'm going to tell you what problems to finish. No. Oh, the note. Yes. Oh, yes.
Wait, I thought we didn't.
Note at the bottom. If the instructions ask for standard form, you have to multiply the factors out. Have to. If they ask for linear factorizations, you do not. Pay attention to your instructions. All right? You'll save yourself a lot of time and energy. Okay.